Hello guys, I am Nidhishri Swagalwadi, your science teacher, Sankalp Learning Solutions. So in the last class in the chemistry, we learned regarding decomposition reaction where one reactant broken down into two or three simpler products. For this reaction, the energy is needed. So we can say these are endothermic reactions. The energy might be in the form of a heat, the energy might be in the form of electricity, and the energy might be in the form of a sunlight. Based on the type of energy it is absorbed, we can see we have three types of decomposition reaction: thermal decomposition, then electrolysis, then also the photochemical decomposition. As I said, in the next session, means today's session, we are going to watch the laboratory method regarding the thermal decomposition reaction as well as electrolysis. Let us begin. So here for the thermal decomposition reaction, you have an activity which will be visualized now through a video. Watch it and learn it.
Hello, scientific brilliant people. How are you today? So today I'm going to demonstrate a thermal decomposition reaction of PbNO3 whole twice. That is.
Okay. So as you can see here, sir used a Bunsen burner. I am saying the required materials for the, just a minute. Okay. So the required materials for the experiment. So we need a test tube for it. Okay, we need a test tube. Then they used, or he used, a chemical lead nitrate, which we wrote the reaction in our last session. So when lead nitrate is heated, okay, so it decomposed into lead oxide, nitrogen dioxide, okay, and with the liberation of oxygen. So we need Bunsen burner, we need lead nitrate chemical, we need a boiling tube, and we need a pair of tongs. This is a spatula or a spoon like, which is used to put the lead nitrate. Let us see how they will perform an activity and what all the careful measures or preventive measures to be taken while performing this activity. Just a minute.
Lead to nitrate, and for this experiment we require a Bunsen burner, we require a test tube holder, we require a test tube, we require PbNO3, and PbNO3 whole twice lead nitrate is white in color, and I have already taken some amount of lead nitrate in the test tube, right?
So as you observed, the color of lead nitrate is white color salt. Okay. So it is taken in a boiling tube, or we can say a test tube, which has a more capacity. Now he is heating the lead nitrate. Let us see what happens.
So I already have this PbNO3 whole twice over here. Plus we also require an incense stick to check the presence of oxygen. Now the reaction goes as under: the lead nitrate PbNO3 whole twice, it decomposes in presence of heat to form lead oxide plus nitrogen dioxide and oxygen gas.
Fine. So he also used a incense stick, or we can say it is as agarbatti, to check whether a released gas or a liberated gas is a oxygen. Let us see how the activity is performed.
Nitrogen dioxide is a toxic gas and it is reddish brown in color, and oxygen gas can be checked by the help of the incense sticks. So now let's proceed the experiment. We need to heat it a bit strongly.
Okay. So while heating in the laboratory, while heating method is involved, the test tube should face the walls. It should not face to the face of any person beside you, or it should not face your face. The mouth of the test tube should be faced towards the walls, so that if suppose a poisonous gas or the toxic gas will be the product of the chemical reaction, those products will not be inhaled by you or will not create any problems for others. So always hold the test tube towards the walls whenever you are practicing heating procedure, and don't perform this activity without a teacher. This activity should be demonstrated or practiced under the guidance of a teacher only.
As you can see, the decrypitation is taking place. As you can hear the sound, crackling sound.
As you heat, you can hear the crackling sound of it when you are heating. Now just observe what are the changes occurring in a test tube. Lighting incense stick. Okay, when the ignited incense stick
As you
is
can see,
putting
the reddish
inside
brown
the test
fumes
tube.
have started to come out.
As you can observe, the reddish brown color at the bottom of the test tube, it is nothing but the formation of the nitrogen dioxide, which is a very poisonous gas.
And now let me put the burning incense sticks inside.
Now sir is inserting the incense stick inside the test tube to confirm whether the released gas is oxygen or no. So whenever you put the incense stick inside the test tube, the incense stick will catch the fire soon. If it is so, it is confirmed that the released gas is oxygen. Let us see what happens to the incense stick now.
As you can see that the oxygen gas is making the flame more brighter.
See the flame?
Oh, done.
See.
Superb.
The flame again,
So as you can check the presence of
got
oxygen
the
gas
flame.
with the help
It
of
is
burning
due to
splitter.
the oxygen gas. Check.
The oxygen gas
Hina.
burns the splinter, and here we have the NO2 gas as well. So hopefully guys, you have understood the demonstration.
So this is regarding nitrogen dioxide, the reddish brown fumes, whatever you are seeing, these are nothing but the
Please make
nitrogen
sure that this reddish brown
dioxide vapors, which should not be inhaled because these are toxic. So this activity shows us the thermal decomposition of lead nitrate into lead oxide, nitrogen dioxide, and oxygen. This is about the thermal decomposition reaction. Now let us see one more type of decomposition where using the electricity as a form of energy, the substance is going to split. Here we are using a common substance that is nothing but a water. We know that water is made up of H2O, that is two atoms of hydrogen and one atom of oxygen. How we will come to know the water is made up of H2O only? That is by the electrolysis or a decomposition of a water. So let us see how that activity is performed. And this activity can be performed at home also using the available materials at our home. We can perform this activity using 6-volt battery only under the guidance of the parents. Now let us watch the activity and what is done during that activity. Just a minute. Okay, let us watch the video on electrolysis.
Hello everybody. So today I'm going to demonstrate the electrolyte.
So this is regarding the required materials for electrolysis. Here we need two pencils which are sharpened at the both the ends. Okay, and we need a cardboard, we need a battery of 6-volt, and we need a cup which is transparent. Okay, and we need the wires. This is a simple arrangement of the apparatus. Let us see how it is arranged.
Of water using a very simple apparatus. So we have got two pencils sharpened at both the ends. Then we have a glass of water. Then we require a cardboard, and we need to make two holes through which the pencils can go inside. And we require a 9-volt battery. The battery is connected with the leads of the pencil. Now this black wire is connected to negative terminal of the battery. So this is the cathode, and the red wire is connected to the positive terminal of the battery. So this pencil is the anode.
So what he did is, he inserted the two pencils inside the vessel which is containing the water, and the pencils are fixed with the cardboard, that is they should not move while experimenting, and both the other ends of the pencil are connected to the wires. As he said, the red wire is connected to the cathode and the black wire is connected to a cathode, that is a positive terminal. Red wire is connected to anode. So let us confirm it. Check.
And the red wire is connected to the positive terminal of the battery. So this pencil is the anode. Now, as you can see,
okay, red wire is connected to positive terminal of the battery, that is blue color pencil is a anode, positive terminal, and the Apsara pencil, what you can see, it is connected to negative terminal of a battery. So consider it as cathode. Now, both the wires are connected to both the terminals of the cell, and as the experiment proceeds, you can see certain bubbles at these ends. Both the pencil will be getting the bubbles. Please concentrate on the pencil where the bubbles are rising upwards very soon. Okay, where the bubbles are rising upwards fast, in a very speed, where the bubbles are rising fast.
That pure water is a bad conductor of electricity.
So as we know that pure water is a bad conductor of electricity, we should add some salt or an acid so that it will conduct the electricity. Let us see how the experiment proceeds.
So I have added some good amount of salt inside this, and you can see the bubbles have started to come out. There are large number of bubbles coming out from here. That means these bubbles are of the hydrogen gas, and
so you can see that you can observe large bubbles are coming out from here. You can see more bubbles here, but these are not coming out. These are not coming out very in a speed motion. So where the bubbles are coming out in a fast manner, so that is a hydrogen gas. Where the bubbles are not coming, are just attaching to the pencil, those are oxygen gas bubbles.
Less number of bubbles are coming out from here. Please don't look at the bubbles which have settled on the graphite, but the bubbles which are coming up, rising up, they are very, very small and hardly visible, but less number are coming up. You can see over here, but it is very much visible that large number of the bubbles are coming out from here. So this is the hydrogen gas and this is the oxygen gas. So hydrogen gas is emitted at the cathode, and
so hydrogen gas, where large number of bubbles are coming out, that is a hydrogen gas, that is Apsara. So there at the cathode hydrogen gas is coming out, whereas at anode oxygen gas is coming out.
And the oxygen gas is collected at the anode. So very simple setup, as you can see by yourself. Volume of hydrogen and the oxygen coming out is 2:1.
See, what is the formula of water? H2O. Why it is H2 only? Because volume of hydrogen gas is double time than compared to the oxygen gas. That is why the formula is H2O. Let us look at it by a schematic diagram.
So let's try to understand that.
So now, after seeing the demonstration, let us learn about the equations that are related to the electrolysis of water.
See, for that we learned an experiment. So that is used or explained in the form of a diagram here. So in the beaker, a water is there to which a salt or an acid is added. So where cathode and anode, two electrodes are here. Anode is connected to a positive part, cathode is connected to a negative part, and we know that at the cathode we will be having hydrogen. Just a minute. Yeah. So at the cathode we will be having hydrogen. Hydrogen gas will be released. I think I should take the other color. Fine. H2. At the anode, oxygen gas is released. Okay, we confirmed it by that activity. Let us see how reaction proceeds here. Okay.
So we know that pure water is a bad conductor of electricity. It will not allow the electric current to pass. So we add some amount of salt, and instead of salt, you can also use dilute acids. So we can also use sulfuric acid or any other salts or acids, separate out. Now there are free ions inside the
reactions
water.
at anode.
So
what happens to the
water becomes
reactions at
that.
anode? We will
Okay,
see now.
so this is our anode connected with the positive terminal
Okay.
of the battery. We generally use platinum or graphite rods. Graphite is ideally not.
So usually platinum rods or graphite rods which will be used, and we know that at the anode we have oxygen gases. Let us see what will be the reaction there.
Over there, but for school demonstrations, that's perfectly fine, right? Ideally, we carry out this electrolysis of water in a specialized container called Hoffman's voltameter. So here, this is our positive anode, this is negative cathode, this is acidulated water, electrolyte, right? And we are going to perform the electrolysis of water. So when you pass the electric current, the current flows through the entire circuit like this, and water gets reduced. So let us see what happens to water. Water breaks down into HOH. Always remember, guys, you have to write water as HOH. OH is hydroxide ion -1. This is
so the decomposition of water gives us H plus ions and OH minus ions. Let us see what happens at the anode.
Current, or the moment you add acids into water, the acid breaks down into hydrogen ions. There are 2 atoms of hydrogen.
Okay, as we know that we are adding acid or a salt inside the water, let us consider we are adding acid called H2SO4. So when the electricity flows, H2SO4 will also broken down into H plus and SO4 2 minus ions. Okay.
So you will basically get 2 hydrogen ions and 1 sulfate ion. Now there is going to be 1 hydrogen ion and 1 hydroxide ion when 1 water molecule breaks up when you pass the electric current, correct? Now inside this water, so now we will go to the cathode, and OH minus is negative, so it is going to go towards.
So we know that unlike charges repel each other, cathode is negative, so H plus ions will go here. Anode is positive, OH minus ions will go at anode. Okay.
Anode, right, guys? So this OH minus ion will gather at anode. So whatever happens to OH minus ion, it is happening at cathode. So under the reaction at cathode, I am going to mention OH -1, and whatever happens to H plus 1 ion, it happens at cathode, because this positive ion is going to get gathered at the negative ion will lose electron, positive ion will gain electron. And always remember, at anode, oxidation takes place, and at cathode.
So at anode, the oxygen will be removed, so oxidation takes place. At cathode, reduction takes place as hydrogen is added.
Reduction takes place. It is being taken up by anode, then this positive terminal.
So like this, OH minus ions will get the electron to become OH. H plus ion will lose the electron to become H2 or H. This is how the water splits as hydrogen and oxygen, and this is about the electrolysis. We have one more decomposition which is called photochemical decomposition. So this photochemical decomposition involves the using the sunlight, the chemical will break into simpler molecule. For example, when you wear the silver ornaments, after a few days, they will lose their shining property. Why? Because the silver in the ornament will be decomposed in presence of sunlight. Okay. Okay, just a minute. Okay, so as you can see here, let me, okay, fine. So here AgCl2, okay, AgCl2, that is silver chloride in presence of sunlight, okay, in presence of sunlight, it will be sunlight, okay, it will be decomposed into Ag and Cl2. Ag and Cl2. So this is how photochemical decomposition occurs using the sunlight. This is regarding the decomposition reaction. In the upcoming session, we are going to discuss a lot more other types of reactions. Until that, take care. Have a nice day. Bye-bye.